time, welcome everybody, and can I please introduce Liz Evans. Liz is a wonderful volunteer. We're very grateful for all her efforts. Herself and Anne Rainbow and Leah and a few other people have organised this whole series of webinars pretty much on their own, off their own bat, and we're very appreciative to have such wonderful people with us. So thank you, Liz, to kick off. And if I may, let's get started.
Ben, can everyone hear me okay? Is that a decent volume? Excellent. Okay. So I wanted to say welcome as well to everybody, and I believe we've got about 140 RSVPs. We've got about 40 people in there at the moment, which is fantastic. This will probably be our biggest webinar that we have held to date. So yeah, it's been great to be a part of VFCA. I joined as a volunteer probably back in February. And essentially, you know, what leads all of us to veterinary science or related professions is the love of animals, and that's where I come from. And I guess I've been interested in climate change for quite a long time, but I think the bushfires and the 3 billion animals that have died in those fires has really hit home to a lot of people, including myself. And really, climate change is always something that was for the future, but it's here now. And I think the talks that you'll see today will emphasise that you know, we're in the middle of it. It started, and we need to do something to turn it around. So there's no time to waste, and that's where I'm coming from and why I've volunteered with Vets for Climate Action. And I think the other thing is that Australia could be a better leader in this area. We've certainly been a laggard, and I think, you know, with people like Morris Johnson saying today to Scott Morrison, you know, you guys should really start doing more. And Japan also looking at net zero by 2050, I think it was. These are signs that the world is changing, and Australia needs to get on board. So we think it's time that as vets we stand up. Animals don't have a voice. We probably are the only voice that animals are going to have. So it's time for us to stand up for those animals that we love and need. So we've got a great bunch of people here. I've really so far enjoyed working with a number of us. I'll just mention a couple of people. So Ben, who you've met, is our CEO. He's our tech guy today. So if you have any issues, tap him on the shoulder somehow if you can. So I think you've heard from Ben. Also, I'd like to just quickly introduce Anne Rainbow, who's a stalwart of volunteering, and she's done an amazing job getting people on board. Do you want to say a couple of words, Anne?
Yeah, just hi and welcome to everyone, and I'm excited about what will happen today and going forwards.
Excellent. And Jeanette Kessels is our chair of the board of VFCA. I'll ask Jeanette to speak at the end briefly. She's a fantastic leader, and she's been a real inspiration to us all in this area. So thanks so much for being around, Jeanette. I'd just also like to say that in the spirit of reconciliation, we acknowledge the traditional custodians of country throughout Australia and their connection to the land, sea and community. We pay our respect to their elders, past and present, and extend that respect to all Aboriginal and Torres Strait Islander peoples today. And we acknowledge that sovereignty was never ceded. Okay. So we want to make sure everyone's comfortable with Zoom. I think you guys know mostly how to use it. If you do have any questions, we'd like you to put them in the chat. We don't know how we'll go for time, so if we do get enough time, we'll try and get a couple of questions answered. Otherwise, we'll endeavour to collate those at the end and maybe send them around by email. So we'll do our best to do what we can there. So put them in the chat. If you don't know how to use the chat, I'm going to give you Anne's number right now, and you can give her a call. So it's 0416 445 581. So that's 0416 445 581. If you have any issues, just give Anne a call, and that also goes for down the track if you want to know more about Vets for Climate Action. I'd like to thank also some of the key vets that have joined us today. We have many key vets here, but in particular Mark Shipp, the Chief Veterinary Officer of Australia. Would like to welcome him. We've got a number of former CVOs here today, Ken and Ian, and I think others as well, Ron. So thank you so much, guys, for coming. And a lot of this is about the letter that you put together. We've got members of the AVA. We've got people from CSIRO, DPI. We've also got a number of my friends and colleagues from industry, from companies like Elanco, Zoetis, Boehringer and Green Cross. So thank you all for coming. It's really greatly appreciated that you've put aside this hour to spend with us today. So you may be aware that 18 former CVOs met together and decided to write a letter to the Prime Minister. basically outlining the devastating impact that climate change is having on our animals. And unfortunately, the PM gave a standard letter response back, which was a little disappointing, and he didn't want to meet with the CVOs. So we just want to have a look at that today and see what was said there. What does it mean? And so we've asked two of our preeminent scientists to join us to help us understand this space. So as veterinarians and in other professions similar to vet, we don't necessarily understand a lot about climate science. And so part of the reason for having this seminar is to get everyone up to speed. You know, what is the data showing? What's the current data look like? What are the impacts going forward? And I think you'll find Mark's presentation quite engaging in that regard. Today we're going to start with Mark. So Mark Howden will kick off, and he'll give a lot of the latest climate data. And then Lesley Hughes from Macquarie University will join us. And I'll introduce Lesley after Mark's presentation. And she will talk more about the CVO letter and in particular the response from the Prime Minister. So starting with Mark. Welcome, Mark. Thanks once again for joining us. We know how busy you are and it's a tough time at the moment for you, so thank you so much. One thing, I'll just briefly explain Mark's background in that he is a professor, obviously, director of the Climate Change Institute at the Australian National University. He is also an honorary professor at Melbourne University and vice chair of the Intergovernmental Panel on Climate Change and a member of the Australian National Climate Science Advisory Committee. Mark has over 420 publications of different types, and he helped develop both the national and international greenhouse gas inventories that are a fundamental part of the Paris Agreement, and has assessed sustainable ways to reduce emissions. He's been a major contributor to the IPCC since 1991, with roles in the 2nd, 3rd, 4th and 6th assessment reports, and was a Nobel Prize recipient in 2007. So we couldn't really be in better company than with Mark. Mark, one thing that has come to light is that you are a keen home brewer, I believe. But not only that, but you grow your own hops in your backyard and then you make your own beer. So how did you get interested in that? I'd be keen to know that first before you start on your presentation.
Thanks, Liz, and thanks Ben and Jeanette and Ron for getting me here today. And before I answer that, I'd just like to acknowledge the traditional owners on the lands on who I stand as the Ngunnawal people and pay my respects to their elders, past and present. Beer, I mean, it started off when I was at uni, and when I was young, I brewed my own, and then it lapsed for a long time, and then a few years back, I picked it up, and I encountered someone who had some hop rhizomes to grow, and so I started to grow them as well. And I haven't tried this, but my local brewer, who is actually one of Australia's best, it's a fantastic brewery called Bent Spoke. They've actually offered to make a beer with my hops. So, so that's actually pretty. I was pretty pleased when I heard that one.
Excellent. So you don't need to visit the local breweries now. You just stay at home. Fantastic.
Absolutely. But so do you want me to kick off the presentation? Yep.
Yes, please, Mark. That'd be fantastic.
Okay. Ready? I'll just share my screen and I'll just check that it's working. So share and so that should be coming up as a full screen.
Yep, that's working well. Thank you, Mark.
Excellent. So I'm just going to do a really quick cover of what is an incredibly complex topic and sort of try to bring together a few different elements about what's driving climate change, what it might do in the future, and a little bit at the end on implications for animal husbandry, greenhouse gas emissions, and the role that vets might play in that. So it's firstly, I'll look at what's already going on in our systems, and one of those things is greenhouse gas emissions. We hear a lot about that. It was, I think it was Liz who just made a comment with the Japanese Prime Minister just making an announcement about net zero by 2050 for Japan, third biggest economy in the world. You know, we heard a similar announcement from China just before, and quite a few other countries have made similar commitments. But in spite of those commitments, what we're seeing is that greenhouse gas emissions continue to go up on a global basis. And this graph goes back to the 1990s up to last year, and you can see that there's a long-term increase. And in spite of increased renewables, etc. over the last few years. The last couple of years have had considerable increases in those emissions. So these are emissions in billions of tonnes. They're from fossil fuels and cement manufacturing and similar things. To get the full number, you've got to go and add about another 15 on top of this. So we're about 53 billion tonnes of carbon dioxide equivalents per year. And we've known for well over 150 years that if we pump out these greenhouse gas emissions, we will warm the Earth. Essentially, these greenhouse gases, particularly carbon dioxide, acts like a blanket in the atmosphere, and it saves some of the heat that would otherwise escape out into space in the form of infrared radiation. It keeps that in against the Earth, and it keeps the Earth warmer than it otherwise would be. Without the greenhouse effect, the natural greenhouse effect, it'd be a snowball Earth. We'd be minus 33 degrees temperature-wise compared with what we are now. And so we're here only because the greenhouse effect, but the thing is that we're pumping it up because of these greenhouse gas emissions. So the question, of course, is what's going to happen with COVID? So the COVID shutdown has reduced emissions this year. We don't know exactly how much it's going to go down, but probably something in the region of 5 to 7%. And you can see on this graph that that's pretty small compared with what we really need to do, which is go to net zero. And whilst it's a big decrease in historical terms, and there's been a lot of pain associated with that lockdown, it is actually pretty small compared with the changes that we actually need. And the question is, what's going to happen at the end of the COVID period? Do we bounce back in the snapback, bounce back to normal sort of view, or do we go into a green recovery where we actually start to reframe what we do and how we do it? And to put it in context, if say the emission reductions this year are 7%, to meet that sort of Paris Agreement target of keeping temperatures to 1.5 degrees, we've actually got to do that 7% year on year. So 7% this year, another 7% next year, another 7% the year after. And so that is a big challenge, not insurmountable, but it is a big challenge. So to put this in the long-term context, we can do things like drill ice cores. So this is from an ice core produced by the EU scientists, and it shows carbon dioxide levels in the atmosphere through the little bubbles trapped in ice cores going back almost 1 million years. They're going to drill another hole just near this one, which they hope to go back to 1 million or 1 million plus years. But you can see over that period, we've had ups and downs in terms of carbon dioxide concentration, and this is just the natural variability. And so, but you can see that within that natural variability, the Earth system left to its own devices will bounce up between about 180 parts per million and 280 parts per million carbon dioxide. And those are strongly linked to the ice ages. So there's strong feedbacks that generate ice ages and the interglacial we're currently in. But you can see that we're already well outside that natural envelope. So we're already at 415 parts per million, and we're going right up to the top of that graph on current trajectories. And so the critical message from this graph is that if anyone says to you that it's all part of natural cycles, that's just complete rubbish. The natural cycle is what you see down the bottom, between 180 and 280 parts per million. We're already at 415. So we're grossly outside the natural cycles, and we're going up further. And this is definitively due to human activity. Now, as I said, we've known for a long time that if we keep on producing greenhouse gases, we'll warm the Earth. We've been doing this for a long time, since the Industrial Revolution and even before with land clearing. And that's what we've seen. So this is a graph from the IPCC. The blue line is the best estimate of natural variations in temperature, just from volcanic activities and similar things. And you can see that's effectively flatlining over the last 150 or so years. The orange line is the best estimate of human influence through greenhouse gas emissions and through things like land change and aerosols such as black carbon in the atmosphere, and that's going up. If we add the two together, that's the natural and the human, we get the red line sitting in the background, and we can see that corresponds very closely with the observed temperatures over that 170 or so year period. So when we look at, compare with pre-industrial, the temperature is already actually up by 1.1 degrees Celsius. And this year is looking like it's going to be equal to or higher than the previous record year. So in fact, the NOAA in the US says there's a 2/3 chance of it being the hottest year on record this year. And that's in spite of the fact that we've got a La Nina, which tends to cool things down globally in terms of temperature. We may actually get, in terms of global temperature, to the lower of the Paris Agreement targets, which is 1.5 degrees, as soon as 2026 or 2028, depending on what happens in terms of the Pacific Ocean. If we look at our land where you operate in terms of veterinary practices, we're already up 1.5 degrees above pre-industrial because the land is heating up quicker than the oceans. And there's almost zero chance that this is not due to human activity, less than a 1 in 100,000 chance. So if we look at Australia, just at temperatures, it's very, very much the same as the global. We've had this very long sustained increase in temperatures. Last year was the hottest year on record in Australia, 1.5 degrees, 1.52 degrees above the Bureau's baseline, which is a recent baseline, 1961 to 1990. And you can see that trend is long and strong, and we haven't got any plateaus in that. We're not cooling in any significant way. We just keep on heating up. And so last year we had the hottest summer on record. We had heat waves right across the year, and we had the hottest day across Australia, averaged 40.9 degrees. That was a new record, beat the old record by a long way. And the following day, it was 41.9 degrees, beat the record set the previous day. And the third day in that sequence almost beat that new record again. So these are pretty extraordinary when you think averaged across the whole of Australia, it was 41.9 degrees. And that's happening absolutely everywhere. So this is a graph from the Bureau of Meteorology, which shows the area, in this case of the Murray-Darling Basin, which has what would have previously been thought as an extremely hot year. And you can see that nowadays 100% of the Murray-Darling Basin has what would have previously been thought a very hot year. And so the message here, when you look at these sorts of records, is there is nowhere to hide. Everywhere is being affected, and very much in the same sort of vein. Temperatures on average are going up right across the globe. So there's no place where you can go and get away from this. It is a global climate change. If we look at things like rainfall, which fundamentally impact on things like fodder supplies, which then feed our animals, in parts of Australia, not everywhere, that's going down. So particularly the southwest and the southeast, we actually see very significant reductions in rainfall, particularly in the winter. Similarly over in the southeast, but not quite so strong. But up in the northwest, it's quite the opposite. There's been a very long trend to increase rainfall, which has increased availability of things like grass for animal production. Because of these reductions in rainfall, we're already seeing increases in the incidence of droughts and the danger associated with, or risk associated with droughts. And we've seen reductions in flows in rivers in the southwest and southeast. We've seen a really big significant changes in the fire season here in the southeast of Australia. So the fire season now effectively starts 3 months earlier than it used to and finishes 1 month later. So the intensity of fires have gone up, as we saw last year. The frequency of fires are going up. The burnt areas are going up. Last year was the record area burnt in the forests in southeast Australia. And the opportunities for controlled burning, you know, the low risk periods are actually shrinking because the fire danger starts earlier and finishes later. So fire is an increasingly important issue. And if we look at the last of these slides that I'm showing you, tropical cyclones are increasing. And the particular reason why I mentioned tropical cyclones is, apart from the immediate effect, which often is very localized around our coasts, we also see gross effects from large-scale rainfall events, such as the February last year event up in Queensland, which killed, we don't quite know, but something over 500,000 beef cattle. So these animals, there was a drought, they didn't have very much feed. There was a very strong rainfall event up there, which lasted about a week. The animals, there was water everywhere, they couldn't get any feed. They were weak because of the cold temperatures, and huge numbers died. That is by far the single biggest death event in terms of our livestock industry we've ever had. And these things are linked to climate change. And So at a global scale, we've seen more cyclones and they're spreading further south in the southern hemisphere, further north in the northern hemisphere, and they're getting stronger. So we're seeing more of the category 3, 4 and 5 cyclones, the really nasty ones, and those wind speeds on average are increasing. That's what the graph is on the right. If we look at what might happen in the future, so these are, again, going back to greenhouse gas emissions. This is essentially an extension of the first graph that I showed you. So the black line on the left is our historical emissions. The coloured lines on the right are where we might go over up to the end of the century. At the moment, effectively, we're on the red trajectory. I'm heading up to what's called RCP 8.5, which is a world which is 3 and a bit, or maybe 5 or even 6 degrees warmer than our pre-industrial. And to put that in context, typically an ice age is around about 5 degrees Celsius cooler than our historical temperatures. So when we're talking about 3, 4 or 5 degrees, we're sort of talking about ice age scale changes in temperature across the globe, but in the opposite direction. So getting warmer instead of colder. So those changes, which don't sound very much, are really, really significant when it comes to the global systems. If we do what everyone said they'd do on the Paris Agreement in terms of emission reduction, we'd end up with a temperature increase something in the region of 2.5, maybe 3.5 degrees. Unfortunately, a lot of governments aren't doing what they said they'd do under the Paris Agreement, including Australia, and we're lagging behind our commitments. So we're not reducing emissions as fast as we need to. To keep temperatures down to what the Paris Agreement said, which is 2 degrees, or if possible to 1.5 degrees, we've got to go on these emission trajectories, these downwards emission trajectories right now, and very significantly. And the 2 degrees is that blue trajectory there. The 1.5 is this dotted trajectory that I've put in this graph. And you can see the difference between where we're going and where we need to go is massive. And so some people would see this as a real problem. So if I say I'm a coal miner, I'd see this as a real problem because it means that I will not be able to mine that coal and my asset may be stranded. For other people, they see this as an opportunity. So if you're into renewables, for example, or if you're thinking about investment in green steel, then this is a great opportunity. So there is no predetermined sort of consequence here in terms of climate change. Emission reductions is good or bad. It depends on how you actually approach the issue. But regardless, we've got to do it very significantly and very fast if we're actually to keep those temperatures down to 1.5 degrees. Now, the reason why, I'll just give an illustration of what I'm talking about here, is if we actually look at our history of Earth, there's actually a strong and almost linear relationship between the accumulated carbon dioxide emissions and global temperature. And the reason why this happens is when we emit a ton of carbon dioxide, roughly speaking, a quarter of it gets absorbed by the ocean, a quarter of it gets absorbed by the trees and grass and soil, and half of it, roughly speaking, stays in the atmosphere. And it will stay in the atmosphere for a couple of 100 years. And so that means that last year's emissions, half of those accumulate on half of the previous year's emissions, which accumulate on the previous year's emissions. And so when we look at the accumulated carbon dioxide over our last couple of 100 years, we see that's an almost linear relationship with increases in temperature. And we understand the science behind this, the process, as well as the empirical data. So that means for any given temperature that you say we want to limit temperature increases to, we can say, well, there's a corresponding amount of accumulated carbon dioxide we can emit that is consistent with that temperature. So for example, if we have a 1.5 degrees goal, which is the aspirational goal of the Paris Agreement, we can calculate exactly pretty much how much carbon dioxide we can emit, taking into account the committed warming, that's the warming that's already underway, non-carbon dioxide gases like methane from livestock, and feedback from things like permafrost breakdown. So when we warm up permafrost, it starts to outgas things like carbon dioxide and methane. And when we do that, the last IPCC report showed that for about a 50% chance of keeping temperatures below 1.5 degrees to the end of the century, we can only emit 480 gigatons more of carbon dioxide. And if you remember, oops, I'll go back one. If you remember that first graph showed you that we're already emitting, just in terms of carbon dioxide from fossil fuels, around about 40 billion tonnes, gigatons a year. If we add on the extras, we're doing 50 billion tonnes a year. And so that means that we've only got about 9 years at our current rate of greenhouse gas emissions before we have to go cold turkey if we are to keep temperatures to 1.5. And so if you think of that from that budget perspective, you've got choices. If you've got a set amount of greenhouse gas emissions that you can spend, you can do that in different ways. You can keep on spending big and then go cold turkey, which is this graph, which it shows 2025. So you keep on emitting at high levels to 2025, and then you've got to close down all of those emissions incredibly quickly. Or you can go on a longer, slower glide path where we start early, and we actually, simply by starting early, it gives us a lower decrease in greenhouse gas emissions to meet the same goal of 1.5 degrees. And so unfortunately, every year that we've kept on increasing those emissions, or even emitting at roughly the same amount, is that we're committing ourselves to more significant, more costly and more risky change in the future in terms of reducing our greenhouse emissions. So there is an urgency element over and above that urgency which arises from our observed things like damage from fires last year, or damage from hail here in Canberra, or damage from smoke, or the coral reef, the Great Barrier Reef getting bleached. So there's urgency from the point of view of climate change impacts. There's also urgency from the point of view of emission reduction. Just what this might mean, 3 slides of what it might mean to Australia, and particularly relating to things that your profession deals with. So heat stress on animals. So if you look at the top left-hand slide, that shows the historical frequency of heat stress days. So this is work that I did 20 years ago. Up in the top end, roughly speaking, 70% of days are heat stress days. Down in around Canberra in the southern parts of Australia, less than 10% of days are heat stress days. Under a scenario which is pretty much consistent with our current Paris Agreement commitments, about 2.7 degrees warmer, what happens is every day across the top end becomes a heat stress day. Those conditions, which typically are experienced in Darwin, spread across about 1/3 of the continent, and places like Canberra experience the sorts of heat stress conditions that previously were experienced in places like Rockhampton. And if you've lived in Rockhampton or Townsville or one of those places, and I have, it's a fundamentally different environment for animals like us and animals like sheep and cattle and horses, etc., or domesticated pets. And so what sounds like a very small number results in hugely different environments in which we need to operate. If we look at rainfall, which is so critical in terms of fodder base for animals, it's so critical in terms of having clean water, management of temperatures, etc. The scenario of changes in runoff, that's the amount, that water that goes into our rivers and dams, are pretty extreme. So these are numbers of percent reductions in runoff per degree of warming. So if you look at the Murray-Darling, it's between 15 and 20. If you look over in southwest WA around Perth, it's about 30% reduction per degree. So if we're going, say, for a 3-degree warming scenario, multiply these numbers by 3. So you end up with half of the water in the Murray-Darling, almost complete loss of water over in southwest WA. And you might think this is extreme, but in the dams of Perth, they've already lost, due to climate change, 85%, that's 85% of their water running into those dams. So when you think about this, this is not an extreme scenario at all. The only variation from this extreme scenario probably is in the north, where there is some possibility of increased rainfall.
Sorry, Mark, just to interrupt, 2-minute warning, if we could, please.
Yep, I'm racing through it.
Thank you.
And the last item was droughts. And so this is a picture of a very recent study done on droughts, looking out to the end of the century. And the message is, as you go further to the right on each of these graphs, there's more and more droughts, which are going to take up both the the sort of length of the droughts and the severity of the droughts is likely to increase as we go through the century. And that varies a little bit from region to region. But the message is increased stress on animals, increased stress on people from drought conditions, driven by reductions in rainfall and increases in temperature. Now, the last slide, Ben, is one about a little bit about what we can do about it. So for starters, in terms of reducing greenhouse gas emissions from livestock. So this is a graph that I produced again 20 years ago. It's relevant today as it was then. So if we look at the bottom axis, this is live weight gain of beef cattle. And so as you go to 1.5 or 2, they're highly productive animals. A lot of animals in poor conditions are more sitting around about 0.5 and even lower under stress. But what this does on the left axis is it's the grams of methane per kilogram of live weight gain. So it's an efficiency metric. And you can see that if you've got animals that aren't gaining much weight, they're incredibly inefficient. They produce a lot of methane per kilo of product. And this is the same whether it's dairy system or whether it's a wool growing system. That same thing is that if you look after your animals, you feed them well, you've got good husbandry, they don't have pests and diseases, they haven't got a tick burden, they're actually going to be towards the upper end of this spectrum, and they're going to be much more efficient, and you're going to be able to produce a kilo of product with a much, much lower greenhouse gas footprint. So you've got a role to play there in terms of improving practice, improving husbandry, which will actually reduce the footprint of those industries. And secondly, there's the climate change impacts on livestock. So increased stress from things like pests and diseases, new pests, new diseases in new places, stress from droughts, stress from heat stress, which you can start to address. And in the same vein, improved animal husbandry, which you're involved in, is actually really important in terms of adapting those animals and those systems to climate change. So I would say that veterinarians have a role both in terms of reducing emissions, the mitigation challenge, and in responding to climate change, the adaptation challenge. And I'll just leave it there. But the last thing that I want to point out here is this picture, which might look really weird. This is a picture taken from a drone of a sheep flock around a feeding point. And the reason why I put it up there is because it's quite startling. It doesn't look like we normally think a sheep flock would look like. And the point that I want to make is that climate change will need to make us look at things with new eyes and take things in new directions. Thank you very much.
Thank you very much, Mike. That was amazing. Yeah, I really like that second last slide. The last one was good too, about perhaps the role that veterinarians can play, especially in rural areas dealing with livestock directly, that we may be part of the adaptation strategy to reduce methane, especially from sheep and cattle. So I think we're going to talk more about that probably in our next seminar when we talk a little bit more about the impact on animals and perhaps some of the adaptations that can be done. So thank you, Mark. As always, those graphs are pretty scary, and I think if you know anyone who doesn't believe in climate change, if there is such a thing as belief, I think those graphs you could definitely share. We'll have them on our website, this talk, and a PDF of the slides on our website that you can share in future with colleagues or with friends or family. Please feel free to do that, because I think when you see those figures, that's what's happening right now, and where we're projected to go. So it's a pretty serious situation.